Experiment to prepare ethine and examine its properties. Ethine C2H2 is prepared by the reaction of water with a substance called calcium carbide, CaC2. Calcium carbide is also called calcium dicarbide. Calcium carbide cannot be obtained in a pure state. It is usually contaminated with calcium sulfide, calcium phosphide, and calcium nitride. As a result, the ethine obtained from it usually is contaminated with gases like hydrogen sulfide, phosphine, and ammonia. These gases are removed by bubbling the gas through acidified copper 2 sulfate. Set up the apparatus as shown. Do not touch the calcium carbide with your fingers, as moisture from your hands could start the reaction. Use the spatula when transferring the calcium carbide to the flask. No naked flame should be brought anywhere near the gas preparation apparatus. Ethine gas forms an explosive mixture with air. Tests on the gas should be performed well away from the apparatus. Double check that you have connected the gas washing bottle correctly. Using the dropping funnel, add water slowly to the calcium carbide to maintain an even, not too vigorous evolution of ethine. Collect some test tubes and a few gas jars of the gas. The equation for the reaction is shown on the screen. Note the formation of white calcium hydroxide inside the flask. Place your hand on the outside of the flask. When you perform this experiment yourself, write down what you notice. In the next part of the experiment, we will carry out a number of tests on the gas. Note the physical properties of ethine. It is a colourless gas with a smell. If impurities are still present, it will not smell very nice. Like methane and ethene, ethine is insoluble in water, but soluble in organic solvents. Combustion. If your teacher allows it, bring the gas jar of ethine to the fume cupboard. Remove the gas jar cover and apply a lighted taper to the mouth of the gas jar. Note that it burns with a luminous smoky flame and a great deal of soot is formed. The soot is formed as a result of unburnt carbon. Addition of bromine. As in the case of the preparation of ethene, bromine can be used to test for unsaturation. Add about 1/10 of a test tube of bromine water to a test tube of ethine. Replace the stopper and shake the test tube a few times. Note that the yellow colour disappears. The very reactive carbon-carbon triple bond reacts readily with the bromine. You are not required to know the equation of the reaction or the names of the products for this course. Addition of acidified KMnO4. As in the case of the preparation of ethene, potassium permanganate can be used to test for unsaturation. Add about 1/10 of a test tube of potassium permanganate to a test tube of ethine. Replace the stopper and shake the test tube a few times. Note that the purple colour disappears and a colourless solution is obtained. The very reactive carbon-carbon triple bond reacts readily with the potassium permanganate. You are not required to know the equation of this reaction or the names of the products for this course. Hence, it will not be discussed further. This concludes the study of the properties of ethine.